Hello everyone. So today we're going to be doing a classical mechanics question in which we have to look at components of velocity and acceleration. So here we are. We have our little boat over here and it's heading in this direction. And basically what happens is that they give us that the boat is accelerating forward at 1 meters per second squared. And they also tell us that the speed of the boat initially is 2 meters per second. And the current of the river is 5 meters per second. So basically what we want to do is from our initial position of the boat, we want to figure out how far downstream the boat will hit the bank. We want to find this point, basically. So let's just call it x downstream. And that's what we want to find. So just defining our components here, we're going to have a y component and an x component. And we're going to use equations of motion for these separately to be able to solve for how far downstream the boat arrives. So let's begin. Let's first consider the y case. So going back to our equations of motion that we memorize or we put on a formula sheet, we get S is equal to ut plus 1 over 2 at squared. Now here, S is our distance, u is our initial velocity, and a is the acceleration. So what we're going to do is we're going to apply this equation in both the x and y components, and that's going to give us two equations of motion, which we will solve to figure out what x downstream is. So let's begin. So considering the y case now, we have this value given to us, which is 100 meters. So we know the distance is 100 meters. We know that our initial speed, which is also given to us, is 2 meters per second. 2 meters per second times time. And our acceleration, again, from the question, is 1 meters per second squared. So 1 over 2, 1 meters per second squared, t squared. So simplifying this now, we get 100 equals to 2t plus half t squared. And that's our equation for the y case. Now, let's do the equation for the x case. So in the x case, we're going to use the same equation here, but this time we're going to see that there's no acceleration in the x direction. So the x direction we have defined this way to be positive. So what we can do is get our direction, which is x, and that's equal to the initial speed of the current times time. So the initial speed of the current is -5. Again, we have labeled this way to be positive, so if the arrow is going that way, we're going to have a negative value. And times time. So again, this is the value that we want to find and that we don't know. So here we go. We want to find out the time it's going to take for the boat to reach 100 meters. So all we have to do is to solve this quadratic equation for t. So let's just go ahead and do that now. We get 200 is equal to 4t plus t squared. I'm going to bring the 200 over on the other side. And now we're going to apply our favorite formula, the quadratic formula, and figure out the time taken. So t is equal to minus b, so minus 4, minus plus or minus b squared, so 4 squared, minus 4 times ac. So a is 1, c is minus 200. And we're going to divide all of this by 2a, and a is 1. So just to make it more explicit here, a is 1, b is 4, and c is minus 200. So great, we have our setup here. We're just going to compute this now. Let's see, minus 4 plus or minus 16 plus 4 times 200, which is 800, I believe, divided by 2. So we're just going to plug this into our calculator and get the solution from it. Okay, so we get a negative solution and a positive solution. So we're going to take the positive solution and we're going to find that that's equal to 12.28 seconds. So that is the time that we want. And we're going to use this time in our x equation to figure out what the time it takes for the boat. Well, to find out how far the boat goes downstream. So great. Therefore, x downstream is equal to 5 times the time it takes. So minus 5 times 12.28 seconds. So therefore, we have minus 5 times 12.28 is 61.4 meters negative. So we find that this value here is minus 61.4 meters. And that is the solution that we want. So we've basically done it. You might notice that in some answer solutions, they have a positive value. And that's because they've defined their axis the other way, where they take y to be up, but then they take that direction of x to be the positive direction of x. But personally, I just find that kind of confusing, so I just stick with the system that usually we're all used to. So there you go, x downstream is equal to minus 61.4. Thank you everyone for watching, and I will see you at the next video.